Chat's not working. It's fine. Or okay. I mean, this one was tough. I was having an argument for the last 10 minutes with myself. If I should stream or not stream. But eventually I decided that I do want to stream. And the reason there was an argument in the first place is because I don't really know what's wrong with my wayland client. Yeah. And I am hesitant to like stream because I don't know what to fix. But then I realized I should just wayland book. Just go through everything. I probably missed something or there's something else I need to do. Obviously. Right, okay. So we'll start at the very beginning. Just go through high-level wayland design, keyboards, touchpads. Never really read this. I just read this a little bit, see if it makes sense. Your computer has an input and output, devices, which respectively are responsible for receiving information from you and displaying information to you. Input devices take the form of these. Your output devices take the form of displays on your desk. These resources are shared between all your applications, and the role of the wayland compositor is to dispatch the input events to the appropriate client and to display the windows in the appropriate place on your outputs. The process of bringing together all your application windows for display on an output is called compositing. Okay. And thus we call the software which does this the compositor. Okay. And I've seen people write their own compositor as well. It should be fun, but I guess I digress. There are many distinct software components in desktop ecosystem. There are tools like Mesa for rendering. Excuse me. The Linux KMS/DRM is a subsystem. I have seen this before. Buffer allocation with GBM, the user space libdrm library, libinput, evdev, and much more still. And in fact, wayland protocol is quite conservative and abstract, and a wayland-based desktop could easily be built and run most applications without implicating any of the software. That being said, surface level understanding of what these pieces are and how they work is useful. That's it streaming. Oh, okay. I think the stream just disconnected. Am I not connected? Internet looks fine. Okay, we start again. So basically, I am kind of stuck with my wayland client, the fact that I can't get a window. So I'm going through the book again to see if I missed anything. Long story short, GPU is stated in the form of memory for storing pixel buffers and jobs like scanning out these buffers to your displays. Your GPU also provides a processor which is specifically tuned to be good at highly parallel jobs, such as calculate such as calculating the right color for each of the pixels on a 1080p display, and bad at everything else. Okay. The USB controller has an unenviable job of implementing the legendarily dry USB specification for receiving input events from your keyboard or instructing your coaster to assume temperature. On system, the hardware provides interfaces which can be commanded to perform work and does what it's told, regardless of who tells it. For this reason, only one component is allowed to talk to it. Interesting. Yeah, that makes sense. Responsibility falls into kernel. The kernel is a complex beast, so focus on the parts relevant to Wayland. The next job is to provide an abstraction over your hardware so that it can be safely accessed by user space. Where our Wayland compositors run. Graphics is called DRM, Direct Rendering Manager, which efficiently tasks the GPU with work from the user space. An important system of DRM is KMS, kernel mode setting, for enumerating a displays and setting properties such as their selected resolution. Input devices are abstracted through interface called evdev, or there was another name for it, libinput. Most kernel interfaces are made available to user space by way of special files in dev. Interesting. Actually, I didn't know that. In the case of DRM, these files are dev/dri/dr. And how do you find? Interesting. What if I delete one of those files? Usually in the form of primary node card 0. I guess it also, like, you connect a local socket like Wayland. Mode setting, render mode, privileged operations like rendering or video decoding. For evdev, the device nodes are dev input event, Interesting. These like each of the 1, 2, 3, 4, 5, 6. Okay, I wonder if these are like the individual ports. No, that's an output. 1, 2, 3, 4, 5. Could be. I don't think I have 15 input devices. Anywho, now we enter user space. Here, applications are isolated from the hardware and must work via the input nodes provided by the kernel. Most Linux interfaces have a user space counterpart which provides a pleasant-ish C API for working with these device nodes. One such library is libdrm, which is user space portion of the DRM subsystem. libdrm is used by Wayland compositors to do mode setting and other DRM operations, but is generally not used by Wayland clients directly. Mesa, one of the important parts of the Linux graphics stack, provides, among other things, vendor-optimized implementations of OpenGL and Vulkan for Linux, and GBM library, an abstraction on top of libdrm for allocating buffers on the GPU. Most Wayland compositors will use both GBM and OpenGL via Mesa, and most Wayland clients will use at least OpenGL or Vulkan implementations. Okay, lib input. What is udev? As from the kernel, confirm permissions for resulting device nodes in /dev and sending word running on your system is responsibility that falls into user space. Most systems use devices and GPUs and to receive notifications when ones appear or all ones are unplugged. XKB common. Short for X keyboard. Oh, okay. And is the original keyboard handling subsystem of the Xorg server. From the Xorg tree and made into an independent library for keyboard handling. It's no longer has any practical relationship with X. Codes from scan codes whose precise meaning varies from keyboard to keyboard. Translate these codes meaningful generic key symbols. For example, it's a state machine which shows that pressing 1 will shift is held emits. Okay. Pixmap, a symbol library used by clients. I think that's what we used in X11. I like to efficiently manipulating pixel buffers, doing math with intersecting rectangles and performing other simple pixel manipulation tasks. Lib Wayland and consistently found throughout the desktop ecosystem. Beyond this, more components exist. Many graphical applications don't know about Wayland at all, choosing instead to allow libraries like GTK+, Qt, STL, GLFW, among many others, to deal with it. GTK+. Many one. I think that's why. Interesting. Because I know that like Ghost uses GTK. So the Wayland debug things that we see is through GTK. Many compositors choose software like WL Roots to abstract more of their responsibilities, while others implement everything in-house. WL Roots. Okay. What's in the package? You know, the crazy thing is, all of this was here. I read through it. Oh, when it came down to like actually doing this, I totally forgot about all of these. I think most of this, the wire protocol stream 32 bits, encoded with host byte order. These values represent the following primitive types: int U30, U32, and I32, fixed, 24 8-bit signed, fixed point numbers. Object is 32-bit object ID, new IDs, object when received, string is like length, and then data padded with null terminators. Array is the same. FT 0-bit value on the primary 0-bit value on the primary transport, but transfers a file descriptor to the other end using the ancillary data in the Unix domain socket message. Yeah, this is the bit. I did find something yesterday when I was going through some of my code. I think, was it message header? What did I call it? IO. There were a couple of mistakes. For instance, I was sending control message as bytes. Realized you can just pass instruct because it's And what else? Yeah, my control len was also wrong. So math actually, this can't this be size of? I think just can just be type of size of type of control message. Or should it be? Yeah, that does look right. I mean, it feels a bit shorter. You know, I'll leave it as this. It's not really an improvement. Yes, the assertions should now sort of work. Not really. Yeah, I'm still not sure. That should be. Leave that there. Right, okay, let's continue reading. Enum, a single value web map or for an enumeration for known constants encoded into 32-bit integer. Stream of message built these primitives, object IDs, transports. Yeah, I think all of this is, I mean, the socket works. You know how object IDs work. Also understand how messages work. What I want to see. Okay, I do want to check if I send one of the wrong things here. States. Parse. Yeah, I mean, I did notice quite a few inconsistencies. Interface request events, the hype. Yep, I think this one's pretty clear as well. High level protocol. Purpose and precise semantics of each request and event. Alright, let's look at wayland.xml. Server to emit the done event on the return WL callback object. Since requests are handled in order and events are delivered in order, this can be used as a barrier to ensure all previous requests and the resulting events have been handled. Interesting. So I could call... What happens if I don't touch the buffer? Nothing really, so I might be touching it at the wrong time. Let me call try sync. Socket and new ID. ID dot new ID. Let's call it sync ID. What does that mean again? Ask the server to emit the done event. Should have returned callback ID. Emit the done event on the return WL callback object. I think I should send an ID as well. Object ID is U32. That means I can call it on XDJ surface ID. Expected 3, found 2. Do I call it anywhere else? I do. This would be display the registry find ID dot new ID. Well, that looks weird. Should it be display ID? What happens then? What is the event? Turns done. Done. Where is done? Emit the done event on the return WL callback object. So that means if I had WL callback, So there is a callback event here. I don't get another one after I call sync. Something is weird. I think I need to fix the order of things. Don't like this very much. I have an idea. I should get registry, read the event, and then continue. Okay, let me take this, grab that. Paste this here. Where is event ID? I think I might have to grab the whole thing. Get registry. Paste this here. All through wayland server disconnected. Yep, there's not going to be a compositor ID. Hey, Jack Kelly. Yeah. Okay, so this here. Oops. I'm just going to bind to the methods I need. I'm not going to handle this. The else. And the debug document. Handled event. Unhandled object. Object ID. Okay. I think these can just go. Hey, Critipop, you think Zig is better than Go? I don't know. I mean, that's. I don't think that's that question makes sense. I think they solve very different problems. And then it's like saying, is a car better than a tractor? Not that one of them is a tractor. Okay, what is undefined? Just the compositor ID. I think this is undefined as well. I just need the bind IDs. I define them here. Okay, so this should only handle bind. Display ID, I don't need to handle that event. Do I? Yep, in case there are errors. Also, I just realized I'm printing the wrong thing here. Oh, no. But I do need to like break out of this loop at some point. Once I've bound all the IDs. Do next. Okay, if WL, I mean, this is going to be ugly. Compositor ID. What was next? I think it's XD. GWM base ID. ID just break. To do get sync. Right, okay. What are these? So in this loop here, I don't think I need any of this except configure. Object ID, don't need that. Or do I? I think no display event. I don't know, maybe in case there are errors. Don't need that. Callback, probably not. So I guess just the errors and I don't think I need any of these either. Is that an act configure? Yeah, that is. Okay, so what is the order? I forgot. could be done better. Maybe. Think okay, before I get the shared memory buffer, I do need these things. Surface ID is the first thing. Okay, let's start there. Where is surface ID? Commit surface, attach buffer, create surface. There we go. Actually, in fact, I can do something better. Here. Standard debug dot set. Was it WL compositor ID not equal null? DGWM base ID. Oh, and then what was the last one? WL shared memory ID. And then I can create surface. I think this no longer needs to be null in that case. That just becomes that. This will become WL compositor.new ID. This can be const. Okay, once I create a surface, is that an event? Create surface. Create surface. There is no event, so I can continue. And I think the next thing is get xdg shell. Get, is it xdg surface? Don't need this anymore. Yeah, I think it is get xdg surface. Xdg shell, wm base, get xdg surface. Let's get that. Make const surface ID. I mean, this can go. This is xdg surface, xdg wm base, base underscore ID, new ID. This is just surface ID. This is no longer null. Okay. Does this return an event? Creates XTG given surface. Isn't a role corresponding to assigned extending XTG surface? Pop-up, it's illegal to create blah blah blah. This creates an XTG surface. Is used in the basis defined given surface. Just the top level also means blah 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 surface roles. XTG surface to see more details and how it's used. XTG surface. My WL surface. Why this is the desktop style user interface. Required to it provides basic set of functionality required to construct user interface elements requiring management by the compositors such as top level windows, menus, etc. The types of functionality are split into XTG surface roles. Creating an XTG surface does not set the role for a WL surface. In order to map an XTG surface, the client must create a role specific object using get top level, get pop-up, etc. Surface for any given XTG surface can have most one role. Okay. Role must be assigned, yes. Client must call WL surface.commit on the corresponding surface for the XTG surface to take effect. Create an XTG surface from a WL surface which has a buffer attached or committed is a client error. Okay, so it's got to be done before the buffer. So we got to create a top level and commit. After creating a role specific object and setting it up, example setting title, app ID, size constraints, parents, etc., the client must perform initial commit without any buffer attached. And you'll get some events back. So after you get reply to the configure, you can then attach the buffer. Note that a map surface is not guaranteed to be visible once it's mapped. It's committed the XTG surface state and the role dependent state in the surface. Client has committed a buffer to the surface. Okay, I guess let's just do it one at a time. After creating a role specific object, so that means get top level. Let's grab this. Guess, can I just move this here? Then that makes more sense. Get top level, XTG surface ID. This is no longer null. And this neither. Okay, so we've set a role. After setting a role, role specific object. It must be assigned role on not based on XTG surface. Role must be assigned before any requests are made to the XTG object. Surface just for the XDG surface state to take effect. Creating an XDG surface which has a buffer attached. Yep, okay. After creating a role-specific object and setting it up, example by setting the title, app ID, constraints, parents, etc. Do these have to be set? XDG surface. Get pop-up, get that window geometry. Where was the title? I think it was on the surface. WL surface. Offset